Okay, so we're going to look at a specific type of function now for quite a while. We're going to look at a linear function. So a linear function, first of all, we want to be able to tell, is a function linear or not? And it can be in whatever representation. It could be an equation, it could be a graph, it could be a table. We have to figure that out. So I'm not going to read this to you. You're going to pause the video here and read this part. Okay, welcome back. So the way we're going to check if a function is linear is it's got to have a constant rate of change. So what that means is you do have to check the change in x. And each step, so in this step, the x has gone up 1. In the next step, it's gone up 1. And the next step, it's gone up 1. It seems to be constant. In the future, that's not always going to be the case. They're going to try to trick you here by the x's, we're so used to them always going up by 1. They might go up by 1, up by 1, up by 1, up by 2. So they're going to try and trick you, so you got to check that. Now let's check our change in y. Delta y, this is called delta, this little triangle. It means a change in something from step to step. So y was 8, now it's 5. Its change is -3. Each time it's changing by -3. So now what we have to do is record the rate of change. Now a rate is written as a fraction. So our rate of change is going to be delta y over delta x. Change in y over change in x. That's how we get slope of a line. It's y minus y. That's how you find a change in something. You subtract the quantities. So y2 minus y1, that represents a delta y. And delta x is like x2 minus x1. So we're really kind of dealing with the slope here. In this case, because it is a line. So we're going to look at the rate of change. We're going to do it for each step. So on this step, the change in y is -3, and the change in x is 1. On the next step, from 3 to 4, the change in y is -3 over a +1 change in x. On the next step, from 4 to 5, it's -3. The change in y is -3 over a +1. At the next step, from 5 to 6, from 6 to 7, it's always the same in this. From 7 to 8. So all of these reduce to -3. That's our rate of change. And since it happens every step, we're going to say it is a constant rate of change. And that is what makes a line a line. Constant rate of change. If it ever changes in one of these steps, like if it were -3, -3, -3, and then this was a -4, then it would no longer be linear. Okay? So in this case, our change in y was constant. It was always -3, and our change in x was constant. It was always 1. So we got a rate of change of -3. Our rate of change is -3 every single time. Okay, so that's how we can tell from a table. How can we tell from a graph? Well, the root word in linear is line. So that's how we can tell if it's linear, if it actually makes a straight line. Okay? And then how do we tell if it's a function? Because it might not always be a function. We can do the vertical line test. Pass it over and see if it ever hits more than once. It only hits once here, so it is a function. So this one is, yes, it's a linear function. So how do we know? We're going to say, first of all, it's a function. So it passes the vertical line test, and it's a line, right? There's no turns in it. It's a straight line, so that is a linear function. Number 2, is it a function? Looks like it passes the vertical line test. My vertical line never hits the graph more than once, never hits the function more than once, or I should say relation. Right? Now it's a function because I determined it passes the vertical line test. So it's still not a linear function, though, it will say no, because they're asking is it a linear function, although it passes the vertical line test, it is not linear because it is not a straight line. All right, let's look at the next one. This one does not pass the vertical line test because right here, the vertical line hits everywhere. Hits more than once. It hits infinite amount of times. So we're going to say no because it fails the vertical line test. So it's not a function. Even though even though it's linear, it's not a linear function because it's not even a function. Even though it is linear. Okay, so when they ask is it a linear function, well, it is linear, it's just not a function. And then this last one is both of those things. It's a linear function, right? Here's my vertical line test. It hits only once everywhere, so that makes it a function. So we say yes, it passes the vertical line test. And it is a straight line, making it linear. So the first part makes it a function. The straight line part makes it linear. So let's move on here. They ask us to plot the points in the table to create a graph. We want to decide if it's linear and then verify using the table. I'm going to go backwards. Let's do the table first. So we've got to check our change in x on every step. It looks like it goes up 1, up 1, up 1, and up 1. So the change in x was constant. Be careful, it might not always. Let's look at our change in y. Plus 2, plus 2, plus 2, plus 2. Our change in y is constant. If both things are constant, always changing at the same amount independently, then we know it's definitely going to be a linear function. But let's do our rates of change. So our rate of change is delta y over delta x. Change in y over change in x. That's what the delta means. So the change in y in the first step, when we go from 1 to 2, the change in y is 2 over the change in x is 1. On the next step, the y's go up by 2, so it's positive 2. And the x's go up by 1, so it's positive 1. On the next step, it's 2 over 1. And on the next step, the change in y is 2. The change in x is 1. So if I reduce all of those, they all equal the same number 2. So 2 is the rate of change. Darn it, I need a bigger box. And that is constant. So I should say the constant rate of change. It's changing by 2 every time. So is it a linear function? Yes. So I know it's a function, by the way, because none of my x's repeat. Why do I know it's a linear? Why do I know it's linear? Because the rate of change is the same. So I'm going to say because the rate of change in each step is the same, i.e. it's got a constant rate of change. That's what makes it a line. That's what makes a line, right? So now let's graph it and see if it indeed is a line. 0, 1, 2, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. Whoops. Wait, did I do this right? 1, 0 was the first one, not 0, 1. 1, 0. Did that backwards. And then 2, 2 is right there. Sorry, I was off on those. All right, so we got 1, 0, 2, 2, 3, 4, 4, 6, 5, 8. That definitely, if I connect those dots, makes a line. So it is linear and it is a function. Notice that this constant rate of change of positive 2, that actually happens to be the slope of the line, right? I go up 2 and over, so my rate of change in y, my delta y is right here, up 2, delta y, hard to see in purple, should have picked a better color. And then, let's see, let's do a better color. I'll go with this orange, see if that's any better. That's my change in x. So I went up 2 and right 1, so that's why it's 2 over 1. That's my rate of change. Notice it matches what I got from my table. And notice that it's the same every time. The rate of change in y is the same again. I go up the same amount every time. I'm going up 2. See, my rate of change is constant in y and also in x. I always go over 1 on the x. That's what builds a line. So if I'm going up and over the same amount every time, I get a line. It's when it changes from step to step that it won't make a line. It'll start to bend. If it is linear, what's the change in y between coordinate pairs? Change in y over change in x. So I just kind of talked about that. The change in y is it goes up 2, and then the change in x is it goes right 1. So it's going to be 2 is the slope. Since it's a line, we can call that slope. All right, so let's look at the next table. Let me see here. Some of this is going to be classwork. Yeah, there's quite a bit here. So we'll finish this page together. All right, linear function. Yes or no? So first, let's look at the table. It goes, the x is, the change in x is up 1, up 1, up 1. They're not trying to trick us yet. Up 1. Change in y, up 2, up 1, then up 3, and then up 4. So that's my change in y. So now if I make my rate at each step, my delta y over delta x, if I do it for each step, at this, from 1 to 2, the change in y was 2, and the change in x was 1. On the next step, from 2 to 3, the change in y was 1 over 2. 1 over 1, because the change in x was also 1. On the next step, from 3 to 4, it went from 3 to 6. So my change in y was 3, and my change in x was 1. On the next step, from 4 to 5, my change in y was 4, and my change in x was 1. So if I reduce all of these rates of change, they are not constant. They are different rates of change. And this time it's different every time. All it has to be is different once. If it was like change of 2, change of 2, change of 2, change of 3, that's it. One time, it's no longer linear. All right, so is this a linear function? No. And why? Because the rate of change, which remember, that's defined as the change in y divided by the change in x, is not constant. If it is linear, what is the change in y each time? Well, we can't tell what the change in y over change in x is because it changes every time. So what number are we going to put? Are we going to put 2? Are we going to put 3? Are we going to put 1? It's different every time. So that's why, because it's not linear, we don't have to answer that question. So we'll just say it's not linear. Now they want us to graph this thing. So let's see what it looks like. 1, 0 is right there. 2, 2 is right there. 3, 3 here. So we can already see it's not a straight line. 4, 6. 5, 10. Definitely not a straight line. right? It kind of does this, kind of curves a little, then curves back up that way. Not a straight line. So it's not a function, not a linear function. All right, let's check this one. Linear function, yes or no? Let's check from the table. So my change in x from the first step is it changed in 1. Now my x changed by 2. So see, they're trying to trick us here. This one changed by 1. This one changed by 1. Now let's check our change in y. It went down 3. Sorry. Down 3. Then it went down 6. And then down 3. And then down 3. So they're trying to get you to say, no, it's not linear because you can't just check the change in y. That is not the rate of change. The rate of change is delta y over delta x. You got to make the fraction. They're trying to trick you because they show that it goes down 6 in one step. But that's okay because we went up 2 here. So really, we kind of covered 2 steps in 1. So this will be linear because it's always going down 3. But then from 1 to 3, we skipped over 2. So that's why there's 2 changes counted in there. It goes down 3 and then down 3 again. So this is actually okay. And here's how we're going to do this. This is why you got to make those fractions. At the first step from 0 to 1, the change in y is -3 and the change of x is 1. On the next step, the rate of change is, so it's -6 for the change in y and then over a change of 2 for x. On the next step, the y changes by going down 3 while x goes up 1. And on the last one, y goes down 3 while x goes up 1. If I now reduce all of these, I end up getting a rate of change of -3 because this one is also -3. So I've got -3, -3, -3, and -3. So yes, it is a function. Why? You're going to say because it's a constant rate of change. The rate of change which remember is defined as change in y over change in x, is constant. So again, the slope of that line would be -3. Let's graph this line, 0, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 6. 1, 2, 3, 4, 5, 6. 3, 0. 4, -3. 5, -6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. We're going off the graph, like right there, by 1. So you can see that we're always going, our change in y is down 3, right, every time. Down 3 every time. Down 3. We just skipped a step here, that's all. Our change in x is always over 1, over 1, over 1, over 1, and over 1. Right, I should have kept doing our down 3, our down 3. What happened on the table was we skipped over that point. They're trying to trick you. So you got to watch out for that. It's still a line because it's constant. Whoops, that's a terrible line. So if it is linear, what's the change in y over the change in x? So they're saying, what is the rate of change? We already did that up here. We reduced them all. Or you can look at the slope here, right? It goes down 3 and right 1. So the slope is -3. All right, you're going to finish the rest of this next class. So bring it with you.